Okay, our next speaker is another Googler from our Kirkland engineering office working on a totally different project, which is Google Talk, Lessons in Building Scalable Systems. Oh, I didn't say your name. This is Reza Behforooz.
Good morning, everyone. I know this is the last session before lunch, so the more I speak, the later you'll eat. So to motivate you guys to actually pay attention to me, I've put a little puzzle in one of my slides, and there's a small prize for it, so you guys can actually pay attention. My name is Reza Behforooz. I've been at Google for 3 years. I primarily have worked in our communication products. I spent most of my time on Google Talk from its beginning. I've also worked on Gmail, Google Groups, and Orkut, and some infrastructure that's used by our communication products. So before I get started and talk about some of the lessons that I've learned in building scalable systems, I just want to give everyone a quick overview of what we built with Google Talk. So we started by building the actual service that uses the Jabber protocol and an IM client with a bunch of peer-to-peer features, and I'm not going to talk about that at length. And after we launched that, in about 6 to 8 months after that, we integrated the chat experience directly inside of Gmail. And we really focused on blurring the lines between these two different forms of communication. So we added some features like archiving all your chat messages, and when you look at a reply from somebody, you could actually reply back to it, not as an email, but as an IM. And there are a few other features like that that we did with the Gmail team. After we did that launch, we went and worked with the Orkut team so Orkut is a social networking application that Google has. It's incredibly popular in Brazil and in India. And it looks just like it looks like the rest of them. And we integrated the IM experience directly inside of this, and it's actually been very popular in those countries. And as you can see here on this Orkut page, you see all these green and orange balls, and they indicate users' presence, and you can actually click on those and chat with those people. So this application gets a lot of page views, and every page view on this needs to fetch the presence of 10 to 12 people. And more recently, we've launched an embeddable talk gadget that you can put on your iGoogle page, which is the customizable, which is the personalized homepage for Google.com. And you can also put this on any other web page that you have. One of the other features that it has is that you could do inline media. So if in this example, somebody sent me a link to a YouTube video, and I can just click play right there and actually play the video. Well, if you know the answer. So the puzzle is that I was referring to is right underneath the link to the video. Anyone? Anyone? Oh. Well, I guess people in the front have an advantage. But it's basically, well, I do prefer people to sit in the front, and they're all empty. So I think one person read it. So the question is, what is the answer for what is e to the power of I times pi? So if someone knows the answer, you can just scream it out anytime. Thank you. I think you were the first one. So come after the talk, and I'll give you a T-shirt. So at a high level, this is what we built. We have a Google Talk service that's used by all these different clients. So we have a bunch of web clients like Gmail and Orkut and the iGoogle page. There's the Win32 client. There are a bunch of third-party Jabber clients like iChat and Game and Trillion that also can work with our system, and a bunch of mobile applications like on the BlackBerry and on the Nokia devices and Sony and things like that. And we also use the Jabber protocol, so we federate with all the other networks in that domain, and LiveJournal and Jabber.org and Earthlink are a few examples. So most of my talk, the rest of this talk is going to be talking about the Google Talk service, which is basically a set of servers that we built to handle messaging and presence. And let's just talk a little bit about some of the challenges that we faced. So the work that we do is very different from search and other things at Google. We handle a lot of small packets every single day for messages and for presence. So on a typical day, we have millions of users, and we handle billions of these packets that go through our system. And we handle them in less than 100 milliseconds. And at our peak, at the peak hours, the number of the QPS on our servers is in the order of hundreds of thousands. So that's actually pretty significant, even by Google standards. Now, granted, the requests that come to us are a lot smaller than what what the document servers and things like that handle. But regardless, it's still a lot of traffic. Another thing that we have is because of the way we've decided to build the application, all the packets to and from users need to go through both users' endpoints, and both of those endpoints need to apply some business logic. So if I'm sending an IM message to Amanda, my endpoint is going to decide to, let's say, archive that chat message, and her endpoint is going to decide whether or not I have the permission to even send her a message. So everything needs to go through both of these endpoints. And another thing that was very challenging for us is after we launched the system, obviously it's a brand new service. It doesn't have a lot of users. And then we integrated with Gmail, which was a pretty big system at the time, and later with Orkut, which is another very big system. And those things are very difficult to do because overnight you have to take this little system that worked really well for your existing user base and scale it 10x times, maybe 50x times to handle a lot more users. And I'm going to talk about some of the things we did to make those overnight launches actually successful. And finally, one of our challenges has been that we've had to work with a lot of different types of clients and interact with a lot of different Google services that even at the beginning we didn't know that we were going to integrate with. So these are some of the insights and lessons that I've learned. There are 8 of them, and I'm just going to just go through them. The first one is measuring the right thing. Sometimes people come to us at Google and say, so how many IM messages do you deliver, or how many active users you have? And I agree those are very important product questions that measure how successful you are. But they're not really the right engineering questions that can tell you how busy your servers are. So in our world, the hardest part of what we do is managing everyone's presence and showing the right presence to the right people and enforcing all the access controls and privacy policies we have with respect to that. So the number of presence packets in our network is the number of connected users that we have times how many people they have on their buddy list and how often their state changes. So when I log into my Gmail account, I might have 20 buddies, and all of them need to now know that I've come online, and their presence needs to be fetched, and I need to see it. And 10 minutes, if I step away for lunch, for 10 minutes, my presence goes away, and again, everyone needs to be updated. So that number works out to be billions. And as you can see, that growth is not linear with the number of active users that you have. For example, when we integrated with Orkut, they have a lot of friends. So that really changed the amount of traffic that we had in our system, even though the number of users only went up so much. And it's to the point that if tomorrow our users decided not to send any IMs or send 3 times as many messages to each other, it really is not going to make that much difference in our load, since most of the work that we do is with the presence packets. Now let's go back to the Gmail and the Orkut launches and talk about what are some of the things that we did to actually make those launches successful. So weeks before we launched either of those services, we actually launched our servers in productions, and our servers were talking to the Gmail or to the Orkut servers in production, and everything was happening, but none of it was displayed to the users. This helped build a lot of confidence in what we had, and it also helped the other team have confidence in what we had. And with things like this, we generally do a small percentage experiment. We start maybe with 1% or even maybe 0.1%, and slowly ramp that up to larger numbers. So with Orkut in particular, for weeks before we launched, they were calling our servers to fetch presence of people, and most of the times the answer was, oh no, they're not available. But at least we knew that we could handle that much queries from them per second, and we knew that at least from a networking infrastructure, there was not any bandwidth problems between our data centers. And also when our servers failed and we went to another data center and things like that happened, and things were still working correctly. With Gmail, we did a similar thing. When users started logging in to check their email and logging out, we simulated them coming online and offline on our network. And we kind of simulated all the packets that would need to get sent just to see if we can handle all of that. So doing these things for weeks and months before a launch really helps us be prepared for that night where you just turn on this flip and all of a sudden you get a lot more users. So one of the things that everyone today I think have talked about is about Google is sharding. Some people use the term partition to refer to the same thing, but it's basically a way to divide up either your data or your traffic, or in our case, really both of them across a set of machines. And in a Google Talk case, the endpoints that I was referring to earlier are sharded to different set of servers. And one of the things that's very important that that I've learned, and I think most teams at Google do a pretty good job with, is that the number of shards you have need to change. Most of the times you add more of them, but sometimes you move to newer machines that are much more powerful, or you really improve your code, in which case you can reduce the number of shards that you have. And doing any sort of resharding like that needs to be done in an easy way with zero downtime. And that's always a challenge. When you design a system to actually make it like this. Another lesson, and I think out of all of them that I talked about, I think this is probably one of the most important ones, is abstracting your systems from each other so that the Gmail team doesn't know that much about our complexities, or the orkut team doesn't know that much about our complexities. And this is even more important when the systems are owned by different teams that might even be in different offices. For example, Gmail and orkut don't know which data centers the Google Talk servers are in. They don't know how many servers we have. They have no idea what our sharding logic is, what our failover logic is. And that's all great because we can change any of those without ever having to go to them and say, can you make this configuration change on your side, or can you update your code with this? And we've made the APIs between us in a way that we can just do everything that we want on our side, and it's great. So the main way we did this is we built a set of gateways that are, yes?
They don't know what data centers they're in?
No.
How do they know where they are?
So what we've given them is a logical name for where we are. The infrastructure that they use to make calls to us does a runtime discovery to find out which data centers we're in. And so last week, in fact, with orkut, we moved our data centers, and we brought up this new data center, and during the day took the other one. They made no changes on their side, and the RPC infrastructure was smart enough to slowly route the traffic to the new data center. And this kind of thing happens a lot, inside of Google, and it works really well. Another lesson that was important was that a lot of times when you're building applications, you're not really thinking about the details of what happens inside of GFS and Bigtable and some of the other systems that we're using underneath. But it's important to be really aware of them because it is going to impact them. For example, with your RPC system, you want to know if Gmail is making RPC calls to these gateways that I was talking about, are all the Gmail servers going to create a TCP connection to all of our servers, or a subset, and how do we configure that? Or is there any health checking involved? Could that be a problem? Is it just too aggressive? So those are things you need to be aware of and tune. It even goes a layer lower than any of the code that we write. For example, in IM, we handle a lot of open TCP connections. And most of these TCP connections don't actually have much activity. So the traditional pull and select operations in Linux don't work really well for that because the running time of going through the select loop is order of the number of open socket connections, not the ones that are actually active. So there's a new kernel operation called epull that does a much better job with that. And we decided to use that early on, and it made a significant difference. Another problem, or insight that we've had to deal with is, mainly around operational problems. And I've listed a few here, and unfortunately, this list is usually longer than this. So when we first launched, we have a whole bunch of graphs that show the number of interactions between Gmail and Google Talk and the number of bandwidth that we use. And sometimes there were spikes in these things. The spikes happened when all of our users disconnected and reconnected in another data center because there was a downtime. Or when we pushed a new job to our servers and all of our servers had empty caches. So we've worked hard to smooth out all of our graphs so that things like that don't happen. So if users get disconnected, it all just happens in a much smoother way. Another thing that we've spent a lot of time working on is making sure that problems don't cascade into other problems. If a server is sick, it shouldn't accept work. And if you're talking to a server that you think is sick, you should probably just back off and talk to somebody else. And small things like that actually go a long way to make your system very reliable. And as you can imagine, everything that I'm listing here has a bunch of interesting stories behind it that I can't talk about. So the next one, and this was kind of an interesting one. was that any sort of retry logic that you have inside your client and inside of your server could actually become a DOS attack against your own servers. So in one of the early versions of the Google Talk client that was not launched externally, this is like back in the day, it basically, when it came up, it just checked the version and it, against some other place to see if it needs to be auto-updated. And there was a bug in that where there were these clients that were attacking that server that, to see which version they should, the client should be on. And there were 18 Googlers that had these things on their machines, and a few of them were on vacation, and we actually had to go and disconnect their cables because there was a bug in the client that was just retrying in a loop. Luckily, things like that didn't make it outside of the Googleplex. But things like that, that are an issue, and you should be aware of them. Finally, another thing that we've done that has been very helpful is that we run different farms of servers for our different applications. We want to make sure that if Gmail has a problem and they take down their gateways, that doesn't affect Orkut and vice versa. It allows us to have much better SLAs for our clients and and it prevents cascading problems. So I can probably spend a whole hour talking about this. I'm going to keep this pretty short. So any scalable system is a distributed system. So there's a bunch of regular distributed systems problem that you need to solve. For example, you need to have fault tolerance in every component that you have. Everything that you think is reliable will eventually fail. And so we've done a pretty good job with that. Another thing that we did is, when you run these servers in production, you could do any sort of CPU profiling on your machine, but you want to know what's happening, what's slow in production. So we did a bunch of work to actually be able to do performance analysis of our servers in production without actually affecting their ability to handle live traffic. And that's been instrumental for us to actually improve our code. Another item is really around monitoring, but there's a lot about, when you run a lot of different servers and you have problems, you want to be able to look at what's happening at your system at a very high level. So what we do at Google, and this is used by a lot of different teams, is that we have agents on every machine that collect information about the machine itself, the configuration of the machine, the health of your application, the health of the machine. I mean, even down to the temperature of the motherboard. And all of this information is stored in a repository. And from that repository, you can have real-time alerts. You can have all sorts of pretty graphs. You can go and do time analysis and go back in time and see what happened. And you can notice that, oh, well, after we pushed that binary, these computers are now getting slower, and this other health metric has gone up, and the queues on the gateways have gone up. So you can actually understand what's happening. And that's been amazingly helpful. Whenever we have a problem, the first thing we do is we just go to that monitoring console and start to look at problems. Another thing that's really important at a place like Google, where a user request comes in and it gets dispatched to many backends, and those backends talk to other backends, is that you need to follow a transaction and its context as it comes in and it goes to all of these places. And you need to log enough of this data so that at a later time you can reconstruct what happened and see what's actually slow. So an example of that, with us could be maybe there is a particular backend server that has a very popular user bot that's taking up most of the CPU and is actually affecting the rest of the users. And the hard thing about doing all of these is that you need to make sure that you're doing it in a non-intrusive fashion and not affecting your servers. Yes?
How do you define an intrusive? 1%, 10% overhead?
Well, I mean, it's definitely single digits. If you, for example, logging, most people log debug logs and things like that, and that's generally 1 to 2% of your CPU, and people think that's acceptable. So with everything here, they're as non-intrusive as something like logging. Now, for something like the transactions, there are a lot of different things you could do. You could, for example, decide to only do some sort of sampling, or maybe you can always sample 1%, but when bad things are happening, increase that on some of your machines. So I just wanted, this is my final slide here. I just want to talk a little bit about some of the software engineering practices that we have that has made things very successful for us. One is, every binary that we build on our team and almost on every team at Google, we need to make sure that this thing is both backward and forward compatible. We run lots and lots of different types of servers, and they all interact with each other in ways that we can't even really conceptualize in our head. So the best thing you can do is make sure that you're compatible, because you never know what could, I mean, you can have an old client talking to you. The Gmail team might decide to roll back their build, and you want to make sure that things are always working. Another thing that we did early on that was very helpful was that we have an experimentation framework where we can enable features for a small number of users. Either they could be explicit people or just Googlers or maybe just the percentage of users. And this is not just features. This could be a new caching scheme that we've implemented. And this allows us to actually experiment and see what works really well. And finally, all of our engineers, and this is true for all of Google, have access to the production machines. We can. And this is just amazingly, just empowering. You can just go look at the logs. You can understand what's happening. You can push new builds to them whenever you want. And it's great. And it allows you to experiment and iterate very quickly. And it also makes the system better because you're also, in some ways, in charge of running them. So with that, any questions before lunch?
Question?
Yes.
How often do people screw something up if they have access to all the production machines?
So all of our services have availability metrics, and most of the services have different tiers of servers that we have. So there's always the one server that is really a playground. You can put any build you want on it, and it has maybe 2 test users, and nothing can go wrong. With the more, sorry, I have to repeat the question. So the question is, sorry. So the question is, how do you? Sorry, it's been a long.
Users that are affected by your experiments, and detect it, let me put it this way.
Well, we always know if the experiment was on for what percentage of the users, and we don't enable them to, let's say, 10% at a given time. So I'm not sure. I mean, I'm not sure I understand your question.
Every now and then you make an experiment, you'll screw something up.
Yes, we do screw things up occasionally.
How many users have been adversely affected by your experiments?
I'm not.
1% of your users is 1 million.
There have definitely been cases where the entire system has been affected by a human error, and I think that happens for every system. We don't really have a graph of every experiment that we've ever tried and every bad thing that's ever happened. We take things like this pretty seriously, and not all of the engineers on the team have the confidence to make a big change. It's usually the people who've been around a little bit longer who make the big changes. Yes?
Can you talk a bit about your RPC mechanism? How does the messaging happen between the clients?
Okay, that's a great question. That is one of the Google infrastructures that has not been very publicly discussed. I'm not sure how much of it I can talk about, but that could have its own tech talk. So maybe we can talk about it during lunch or something. Yes.
Can you please talk about the profiling methodologies you use in production servers without
Okay, so how do we do profiling on production servers? So at Google, our servers are written in different languages, and a lot of the original work was done in C++, and there's just amazing libraries designed in that world. Our servers are actually implemented in Java. So, and we were, at the time when we started the project, there were only 2 or 3 systems at Google that were written in Java. So we work with some of the other teams, and we built some new stuff where you can go to a server and say, okay, I want to start profiling, and 10 minutes later you can look at what's happening. Unfortunately, I can't talk too much about it, but in JDK 1.5 and higher, it actually gives you a lot of ways to instrument what's going on inside of your server. And there's also things in addition to the in-process profiling that we do. There's a lot of stuff that we do outside of that by so you can monitor how much of the physical memory of the machine is free, how much of the CPU is free, and things like that. Yes?
Is there any chance you could actually talk some more about the way you do the dynamic sharding?
The what sharding?
Dynamic sharding. What is the strategy for doing this? So obviously it's not a simple task.
So the first step of it is making sure that you have enough abstractions between your servers. So if the Gmail servers knew we had 300 machines in this data center, you really can't do dynamic sharding because you need to restart all the Gmail servers at the same time, and that's just impossible. So the first step is just making sure there's enough layers of abstraction and servers in between where you can do that. For us now, it's a 4-step process. We can do it in less than an hour. If we want to, let's say, have twice as many servers, we take down those servers and their backup servers that are handling the traffic, and then bring up twice as many servers and just change some metadata configuration. And since we use a lot of runtime discovery, since our clients use runtime discoveries, they will just auto-detect that there are twice as many servers. Yes?
You shard across data centers?
The different applications do different things with that. And for us, there's a lot of small packets that are going back and forth, and we want the overall latency to be very quickly. So we don't shard across data centers. We want to make sure that most of the traffic stays within the data center, because going across is usually expensive. I think that's it. So let's go eat.